We're still chapter 9. I don't know, our homework pages don't put what chapter it is. I don't think so. Normally they have it on one side or the other, but nope. Okay. So anyway, here is our math homework. We are still adding like fractions. I call them like fractions when their denominators are the same, right? They're alike. That's how they're alike. So I have 3 over 10 plus 3 over 10, right? This would be 2 times 3 over 10. We're going to learn multiplying next, right? Or soon. Sure, we'll do subtraction first. So 3 tenths plus 3 tenths, I do not add my denominator. I have 3 out of 10 and I have 3 out of 10. If you look down here in the picture, right, they have 3 out of 10 plus 3 out of 10. Right, I'm still breaking them up into pieces of 10, but now I have 6 pieces of 10. I need to reduce that. I can see that 6 and 10 are both divisible by 2. Right, there's different ways to do that. I can say 6 and 10 and find their common denominator. 6 is 2 times 3 and 10 is 2 times 5. They both don't have 3 and they both don't have 5. They both have a 2. So, right, I don't do my 2 times 2. I just keep one of my 2's and I'm going to divide by 2. The top and the bottom. So I'm still dividing, I'm just dividing by 1. Any number divided by 1 is itself, right? So this is an equivalent fraction. 6 divided by 2 is 3. 10 divided by 2 is 5. So 3 tenths plus 3 tenths equals 3 fifths. Right? People see this, they'd be like, what? But you guys are smart. Now you know why that looks like that, why it looks like such a funky problem. How could 3 tenths plus 3 tenths be equal to 3 fifths? Right? It's really equal to 6 tenths, but we reduce it. It's not real, it's equal to both of them. All right, adding, write each sum in its simplest form. So 7 tenths plus 2 tenths, I know you guys already got this, 9 tenths. 13 sixteenths plus 2 sixteenths is 15 sixteenths. Sorry, I should have. This is its simplest form, right? I can't get any smaller. If I find try to find what they have in common. 9 is 3 times 3. 10 is 2 times 5. Nope, nothing in common. I can't divide. Same with 15 over 16. But hopefully you guys can also see this is almost 1, right? It's almost 10 over 10. It's closer to 1 than it is to 0 or 1/2. Right? If it was 1/2, it'd be 5 over 10. So probably 6 over 10 would be closer to 1/2 than it would be to 1 whole. All right, so I'm going to keep going. 15 over 16 is almost also 1, right? It's almost 16 over 16. It's closer to 1 than it is to 1/2 or 0. My next one, 4 fifths plus 1 fifth. So I do not add my denominators. They stay the same. 5. And 4 plus 1 is 5. 5 fifths. Oh, that can go into simpler form, right? Just turn it into a 1. I have 5 out of 5. All right, 7 fifteenths over 2 fifteenths. 7 plus 2 is 9. And my 15 stays the same. Oh, common denominator here. I know 9 is 3 times 3, and 15 is 3 times 5. So, right, this is what they have in common, the 3's. I only use one of the 3's, right? I can't do both of them, so I'm going to do one of my 3's. I'm going to divide by 3 here, I'll divide by 3 here. I'm just finding what the common number they have. 9 divided by 3 is 3. 15 divided by 3 is 5. Next one, 9 plus 3 is 11. Sorry, it is not 11. It is 12 and 20. So, right, an easy thing here, I could see, oh, they're both divisible by 2. I could see that. Hopefully you see something else there too, but I just want to show you one thing I could do here. Oh, they're both divisible by 2. All right, so now I'm going to go 12 divided by 2 is 6. 20 divided by 2 is 10. Oh, wait, 6 and 10, I can still get smaller, right? I see both of these are divisible by 2 also. So I could just do this again, divide by 2 again. Right, I divided by 1, divided by 1, 2 over 2 is 1, 6 divided by 2 is 3, 10 divided by 2 is 5. My final answer is going to be 3 fifths. right there on that little line. So my final answer is 3/5, right? Sometimes I could have just divided by 4 and got 12 divided by 4 is 3, 20 divided by 4 is 5, right? Because 2 times 2 is 4. But I could also break it up and do it twice if I didn't use my smallest denominator. All right, so 5/8 plus 1/8, 6/8. We'll divide by 2. Divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Sorry, one more thing back to this little problem, right? I could have done this too. And then I would have seen this is 2 times 6, and 6 is 2 times 3. This is 4 times 5, and 4 is 2 times 2. So I look what they have in common. They both don't have a 3, they both don't have a 5, but they both have 2 4s. I mean 2 2s, right? I'm not going to use both of them. I'll just pick one of them, and I'll say 2 times 2 is 4. So this is where I could have divided by 4 originally. Sorry, I'm like, some stuff I'm like, oh, that, right, you got that? But I'm going to just show you, right? If I would have divided by 4 and divided by 4, 12 divided by 4 is 3, because 3 times 4 is 12. 20 divided by 4 is 5, because 5 times 4 is 20. And I'm back with my 3/5. I love math. All right, next problem on the back. The table gives the fraction of each type of parade float used in a recent parade. Use the table to answer exercises 7 and 8. I don't know if you guys have been to a parade, but they usually have like cars decorated or little moving things decorated. That's what I call a float, right? You think, it's driving, but they still call it a float, right? When something's floating on the water, it's on the surface of the water. So here are the types of floats. The themes, right? They had a sport team theme, a radio station theme, a high school theme, a dance group theme. I think that's what they're trying to say. All right, so this is the portion, right? I could tell how many floats they had. They had 18. I could add them up. 6 plus 5 plus 3 plus 4. All right, I like to do this. I know 6 plus 4 is 10, and 5 plus 3 is 8. So I'll say 18. I could do a lot of ways. I could say 6 plus 5 is 11, 12, 13, 14, 15, 16, 17, 18. All right, so I could tell these fractions add up to 18 out of 18, which would be all of the floats. What fraction of the floats were either a dance group or a radio station? Sorry, I guess they weren't the theme. They were from a group. This was the sports teams did 6 of them. Radio stations did 5 of them. High schools, there were 3 high schools in this parade, and there were 4 different dance groups in this parade. There was 18 different floats and 18 different people performing. All right, so I'm going to add them up, the dance and the radio ones. So I can see the radio station had 5/18 of the floats, plus the dance had 4/18 of the floats. So I know 5 plus 4 is 9, and I know I keep my denominator the same. So 9 out of 18. You might be like, oh, is there a common denominator here? Yeah, there is, right? I could also find my multiples of these numbers and do it like that way. Right, 9 is just 9, 18. Oh, I see it already. 18, right, would be 1836. So I could see the number they have in common would be that 18 there. Sorry. So I could see there's the 18, right? They both, 9 has 18 in common with it. I was just looking, I guess I'm saying it wrong here, but right, 9, I can see it has an 18. 18 is 18, so I know here if I divide by 9, that's going to work. I know an 18 is 2 9s. A 9 is just 1 9, right? 9 divided by 9, 1. 18 is 2 9s, so I have 1/2. And I would probably write 1/2 were dance or radio. All right. What fraction of the floats were not from a sports team? Right, in the simplest form. The ones that were not from a sports team. right? If I know 6 were from a sports team, I know all the rest were not from a sports team. So I'm going to take my 18 over 18, right? That's all of them. And I'm going to subtract my sports team. I know there's an adding way I could do this as well, right? I could figure out, well, 6, I'll do that after, sorry. So I could do this. These are my total teams. I have 18 out of 18. I'm going to take away my 6 sports teams and tell you how many were not sports teams. 18, take away 6 is 12. 18 stays the same on the bottom, even in subtraction. I'm going to simplify it into simplest terms. So I'm going to divide my 12. Right, I could do my 2's again, but hopefully you see there's a bigger number here that can go into both of these. But I have so much space here, I'm going to show you that other way I did again. So first, right, oh, I see a 2. I could do a 2 into both of those numbers. Oh, that works. Okay, so 12 divided by 2 is 6. 18 divided by 2 is 9, because I know my doubles. Oh, I see I could do one more here. Right, I know 6 can be divided by 3, and 9 can be divided by 3. So I'm going to say 6 divided by 3 is 2, 9 divided by 3 is 3. So I have 2/3. Right? There's a couple different ways I could do it here. And that's the beauty of math. You can do all kinds of stuff. So 2/3 are not sports. So right, there's a few different ways I could do this problem. Instead, I could say, if I know 6 teams, or 6 of the floats were sports, plus I know, right, I'm going to find my gray square here, sum out of 18 is going to give me a total of 18 over 18, right, and I could say I know 6 plus 12 is 18, so I know this is going to be 12/18, right, which is what we got. So another way just to simplify these, if you noticed right here, 2 times 3 is 6, right? And 12 is divisible by 6, and 18 is divisible by 6. So I could have done it that way, right, as well to simplify them, and I would have saved a step. 12 divided by 6 is 2. 18 divided by 6 is 3, right? 6, 12, 18. There's 3 6's in the number 18. So I still got my 2/3. I was like, what was one more thing I was going to show you with this problem? So I better, I don't know if I'll need that much room for this other problem. But I will do it up here. What if I wanted to just find the 6 common denominator that these two numbers have, and I did it this way? I could do a bunch of different ways, right? 16 is going to be 4 times 4, which is 2 times 2. All right, so I'm going to do this. I can see already a problem here. And 4 is 2 times 2. 18 is 2 times 9, and 9 is 3 times 3. So, right, when I was doing this way, it's not quite work for this problem here. And I'm not quite sure why. But, so I'm going to leave this here, but I'm going to do it this other way that we also learned to do it, which is the way I liked doing it first better. 1/16. Right, I know 2 and 8 work together, right? I know 3 will not go into there. 4 will, though, right? 4 times 4. 5 won't, 6 won't, 7 won't, 8. So these are my numbers, right? My 18 is 1 and 18. I can also do 2 times 9. Oh my goodness, I see what I was doing wrong now. I was doing it right. I just needed a 12 here instead of a 16. Alright, so I'm going to scrap this problem now. It would have worked too, right? Then I would have got it. So I could see what I was doing wrong here. I'm doing two things at once. I needed a 12 here, not a 16. right? So I'd say, let's do this again. I'll do the 12 again. So I'm going to say 1 and 12, 2 and 6, 3 and 4, and 5 won't go into 12. So here I'm going to go back here. 1 and 18, 2 and 9, 3, right? 3 sixes is 18. 7, 8 won't go into 18. So now I'm going to look for the greatest common multiple they have here. Sorry, the greatest common factor. Sorry, 6 and 6, right? So that's back to this problem. And sorry, I lost my own attention there. So sorry if I lost you too. But hopefully we could just stick to the first way we did it. I divided by 2, I divided by 3, and I got my 2/3. All right, so Sherry was in charge of distributing 25 food items that were donated to the local food pantry. On Monday, she distributed 8 items. On Tuesday, she distributed 7 items. 5 more items were distributed on Wednesday. What fraction of the food items were distributed by the end of the day on Wednesday? So it's Sherry, right? She's going to deliver 25 food items over the week. So it tells me how much she did each day, and it wants to know how many she delivered by Wednesday, right? It doesn't tell me how many by Thursday she did on Thursday and Friday, but I'll know how many she did both days. I just don't know how much on each day. So I'm going to add these 3 numbers together. So on Monday, I'm going to add 8 25ths items were delivered. On Tuesday, 7 more, so 7 out of 25 of the items were delivered. On Wednesday, 5 more. They did try and trick you a little bit here if you weren't real right. 5, it's written out as a word. 5 out of 25 more equals something out of 25. So I'm just going to add my 8 plus 7 plus 5. Right? There's different ways you could do this to make it a little easier for your mental math. I don't know, 8 and 7 always seems like a hard one for me to add. But I know 7 and 5, it's just, right? 7 is 5 plus 2. So 5 plus 5 is 10, and then the 2 would be 12. Oh, and I know my 2 from my 12 is going to add to this 8 and give me another 10, so I'll have 2 10s, which will be 20 out of 25. And hopefully, right, with your 5s, you know we can reduce this. I could find my numbers, and I should now since I messed up on the other one, right? I was doing it right, I was using the wrong numbers, and I'm like, what did I do wrong? So 20 is 4 times 5, and 4 is 2 times 2. 25 is 5 times 5, right? I just like to do it that way better, but it doesn't even work with the wrong numbers. All right, so 20 is 2 times 2 times 5, and 25 is 5 times 5. So they both don't have 2's, but they both have at least one 5 here. I'll get rid of that 5. So I'm going to divide by the 5 because they both have that 5. So 20 divided by 5 is 4, and 25 divided by 5 is 5, and I have 4/5 of the item. And I am going to put a plural here because it's 4/5 of the 25 items. I'm not breaking one little piece up in a mile up into something. I have a bunch of little items. So 4/5 of the items were delivered. All right, 2 more problems. Complete the sentence with the correct vocabulary word. Both fractions in the expression 1/3 plus 1/3 are examples of, and our whole, right, 1/3 plus 1/3, they are examples of like fractions. I don't know what they were asking for here either, but like fractions is what the vocabulary words they want to know. They are like fractions because they both have a third on the bottom. They are actually the same fraction there too. All right, so here is Gina is working on a jigsaw puzzle, right? You might just call it a puzzle, but it is really called a jigsaw puzzle. Its complete name, its formal name. She completed 1/10 of the puzzle yesterday and 3/10 of the puzzle today. In simplest form, what fraction of the puzzle is completed? So I'm going to add my 1/10 of the puzzle plus my 3/10 of the puzzle, and we will get, my denominator stays the same. I add my numerators. 1 plus 3 is 4, 4/10. I'm going to reduce this to its smallest, right, the smallest number I can. I could do it this way, 4 and 10. I know 4 is 1 and 4 and 2 and 2. Right? I know 10 could be 1 and 10 or 2 and 5. Right? 3 won't go into there, 4 won't go into 10, 5 goes into 10. I look for the greatest common factor there. 2's, it's the 2's. I'm going to divide by 2 on the top and 2 on the bottom, and I've got 4 divided by 2 is 2, 10 divided by 2 is 5. My answer is 2/5. It is